So we're talking about inverse functions today in class, and we started to look at this problem. It says let f of x equal x squared minus 3 for x is greater than or equal to 0, and we're asked to find the inverse of f. We started out by switching out of Euler's notation, otherwise known as function notation. So this f of x just changes out to y. And then the next thing I'm going to do here, as you remember, is just going to actually solve for x. So solve for x. We solve for x, we will get x squared equals y plus 3, right? X squared equals y plus 3. We'll take the square root of both sides, right, to get x by itself. So take the square root here and the square root here. And x is equal to plus or minus square root of y plus 3. We said that we want x to be greater than or equal to 0, so we just have to reject this idea here, the negative part, so that's why we're not going to consider that part here. So I'm going to get rid of that here. And now what we're going to do here to put this into its form is we're going to switch x and y. So here x was here, so make it y. Y was here, make it x. Now I'm going to return this to function notation, but now of course what we have here is the inverse of f of x, and we know that that's equal to the square root of x plus 3. Hopefully we're noticing that there's an issue here also, right? I mean, what is the issue here? Oh, go up the, where are we here? Now there's a issue here. Okay, we're good. Okay, just going to keep moving if you don't mind. So here's our inverse function. Remember, our function was f of, let me put it in colors. Our function was f of x, right? Our function was f of x. So f of x is equal to x minus 3. Right? So far, so good. Now we have to verify this condition, and the way that we verify the condition is this. There are two things that have to be true, and those two things are these. Well, first one that we'll test, if you don't mind, is we'll take f of the inverse of f of x. And remember, that must equal 0. So we'll test that. And what, just the way to see this, if you don't mind, is I'm just going to rewrite this equation right here. I'm going to plug this part in. So I'm going to rewrite this here. We know that we have, right, this is our x squared. This is x squared, and this is the hole where that x squared goes. And this negative 3 right here is this one. But it says we want f of the inverse of f of x. So the inverse of f of x happens to be the square root of x plus 3. So look, I'm just going to pick up that piece, and I'm going to drop it in there. And this piece right here, I'm just going to say, okay, of x plus 3, right? And remember, that's f of the inverse of f of x. Whoa, in a room there. Look what happens here. This is actually pretty clever, isn't it? This square cancels this square root, so that gives us x plus 3 minus 3. So I'm just going to finally finish my math here and say that it's actually true, the thing we were looking for. We're trying to, oh, this is not true here. I said that, didn't I? It's equal to x. It has to be equal to x. I'm so sorry. So when we test that out, f of f, the inverse of f of x. Now we're just going to finish our math here. We have x plus 3 minus 3 equals x. So that works. The second way that we have to verify this is to do that same rule, but the other way around. The other way around. So this time we'll have to take it this way. We'll take it this way, and we'll say the inverse of f of f of x. I'm going to say it right this time. Must equal x, right? Must equal x to verify that. So let's go back and fill in the blanks again. We start with this one here, right? So I'm going to take that again. I'm going to write this, right? Right, I'm using this right here. Right, I'm taking this, I'm using this right here. And I'm just going to fill in the blanks here. Fill in the blanks here. And remember, we have here, this is where we're going to have to put in our f of x, isn't it? We'll put our f of x here. Well, remember, this was x plus 3, so here's my plus 3. F of x, if you remember, is this mess right here, isn't it? So I'll put that in. This x squared minus 3 goes in here. And remember, what we're taking here is the inverse, f of the inverse of f of x. And then look, these parentheses go away, don't they? There's a 1 out here. There's no exponent trapping us here, so we can, these things just satisfy themselves. So they just come down, don't they? So the parentheses come down in this case. I checked. And then x squared minus 3 plus 3, well, minus 3 plus 3 is 0, isn't it? So this goes to 0. So this is 0. That goes away on its own. Yay. And what is the square root of x squared? Well, of course, the square root of x squared, right? This is the index here, and this root of 2 cancels this exponent of 2, so we get x, sorry, we get this. So we have actually proven this out pretty well. So we have proven the fact that the inverse of f prime at x is equal to the square root of x plus 3. Now remember here, there's what I was talking about earlier, there's this domain issue here, isn't there? There's this domain, and the domain is x such that x is greater than or equal to negative 3. If x is less than negative 3, look, let's say that x is negative 4 for a second, and we have negative 4 plus 3 is negative 1. The square root of negative 1 is not a real number. So we do have this domain issue here. All right? So, okay, not simple, a lot of stuff, but go through and look at what we do here. It's the same algorithm over and over. Solve for x. That was the first thing you should do. After you solve for x, switch x and y. Right? Go back to function notation, right? If f inverse of x, or the inverse of f of x here, right? Go back and satisfy the two conditions. This is on page 284 in your text. So here's condition A that we had to satisfy, and here's condition B, and they both have to be equivalent to x. We checked, and they were. We got to the very bottom. We said, okay, we've confirmed that we have an inverse function. Look for any domain issues to the inverse function. We found that there is an issue here, that there are certain x values that will make these numbers cease to be real numbers, and we clarified that with this. So, okay, keep this up. We're going to do a lot more of this stuff, and it's going to get really easy, but you got to hang in there, and you got to practice. What did I do first, second, third, fourth? What are the conditions that have to be met? And check for domain issues. Good work.